Hello students. So in the last video we discussed about some criteria for the congruency of triangles, right? And we uh, understood what actually congruency means. Now we will see these rules of congruency one by one. Okay, so first rule of congruency was side angle side congruency, right? That is SAS congruency, side angle side. So what this rule says that suppose you have given two triangles. This one is triangle ABC, and this one is triangle PQ and R, right? These two triangles will be congruent if the side AB is equals to side PQ, this angle ABC is equal to angle PQR, and the side BC will be equals to the side QR. So in another words we can say that these two triangles will be congruent when two sides of one triangle and the included angle in between them will be equals to two sides of another triangle and the angle included between them. Then only you can say that two triangles are congruent. Let's say when we cannot say that SAS rule is not applicable. Suppose if side AB is equals to PQ, side AC is equals to side PR, and angle B is equals to angle C. In this case, you cannot say that triangle ABC is congruent to triangle PQR just because the angle is not included in between the two sides of triangle, right? So for triangles to be congruent, the angle should be in between the two equal sides, right? Our another criteria for congruency is ASA congruency, angle side angle congruency, right? So according to this rule, two triangles, that is triangle, again let us take triangle ABC and triangle PQR, right? For these two triangles to be congruent, angle B must be equals to angle Q. This side BC should be equals to side QR. This angle C should be equals to angle R, right? So in ASA criteria, two angles of a triangle and the included side between them must be equal to the two angles and the included side of another triangle. Then only you can say that two triangles ABC and PQR are congruent. So now based on these two congruency criteria, let us solve some questions. Okay, let's start from example 1, right? So here it is given that in figure 7.8 OA is equals to OB, right? Means the side OA is equals to side OB and OD is equals to side OC. You have to show that triangle AOD is congruent to triangle BOC. Okay, so here you can see that in triangle AOD and triangle BOC, side AO is equals to side BO. This is given in the question. Side OD is equals to side OC. This is also given in the question. And you can see here that the angle COAB is equals to angle A, or angle, sorry, DOA, right? Angle COB is equals to triangle DOA. So here you can see that this side, this included angle, and another side of one triangle, that is triangle AOD, is equals to side CO, angle COB, and side BO of another triangle. So that's why we can say that these two triangles are congruent. Now second thing that we have to prove is AD is parallel to BC. So for these two sides to be parallel, we need to see that the corresponding parts of these two triangles will also be equal. So this rule is known as CPCT, that is CPCT. Corresponding parts of congruent triangles are equal, which means if these two triangles are congruent, then their corresponding parts will also be equal. That is, this angle A will be equals to angle B, right? So clearly you can see that, as you have studied in previous chapter, that if two lines are intersected by a transversal, right? So you can see these are the two lines CB and AD. If this is intersected by a transversal, that is, this is A point, this is B point. Suppose here it is C and here we have D point. So if two lines are intersected by a transversal, then the alternate interior angles, right, this angle and this angle, if these two angles are equal, then the two lines will become parallel, right? This we have studied in previous chapter. So here you can see that this angle B is equals to angle A. Why? Because of CPCT. We have proved earlier that triangle OCB is congruent to triangle OTA. So corresponding parts of these triangles will also be equal. That means angle OAD will be equals to angle OBC, right? So line BC will be parallel to DA. Reason, because alternate interior angles are equal, that's why two lines are parallel. You can also conclude one result, that is side BC will be equals to side AD, and this angle will be equals to this angle, right? This will also be we can also say this by CPCT, right? So moving on to next example, to see, we are given that AB is a line segment. This AB is a line segment and line L is its perpendicular bisector. That means this line L is dividing this side AB in two equal halves. That is, this will be equals to this side. If P if a point P lies on L, show that P is equidistant from A and B. We have to show that this line PA will be equals to this side PB, right? This we have to prove. So for this you will need to first prove that these two triangles, triangle APC and triangle BPC, these are congruent triangles. Then only by CPCT you can say that side AP will be equals to side BP. So for this, our selection of triangle is very important. So let us consider triangle APC or PAC and triangle PCB. You can see that side AC is equals to side BC, which is given in the question just because C is the midpoint of AB, or L is the perpendicular bisector of AB. Angle PCA, this angle, and angle PCB, this is equals to 90 degree, because it is given in the question that it is perpendicular bisector, right? So these angles will be 90 degree, and side PC is common in both these triangles. So by side angle side congruency, we can say that the two triangles are congruent. So their corresponding parts will also be equal. That means this angle A will be equals to angle B, right? This angle will be equals to this angle, and also this side will be equals to this side. What we were to prove is the side AP will be equals to side PB. So AP will be equals to BP, and the reason will be CPCT, right? The side AP is equals to side PB. reason that you will write here is by CPCT. So in this way you can prove that these two triangles are congruent and side AP is equal to side BP. Now let us move on to next congruency criteria, that is AAS congruency, right? So in AAS congruency criteria, you will see that if in two triangles, suppose these are the two triangles, this is A, B, C, this side is P, Q and R, right? So we are given that these two triangles are congruent by AAS or angle side criteria. So in this, if angle B is equals to angle Q, angle P is equals to angle R, sorry, angle C is equals to angle R, and the side next to angle C will be equals to side PR, then we can say that these two triangles are congruent by AAS criteria. Why? Because angle, angle and side, right? So by AAS criteria these two triangles are congruent, and if these two triangles are congruent we can conclude that the corresponding parts, that is side AB will be equals to side PQ, angle A will be equals to angle P. Why? By CPCT. So moving on to next, see there is no proof for this, these are the experimental data that we have given here, right? So there are no proofs for AAS criteria or SAS criteria, these are just axioms, right, which are the universal truths. So it's, you can see in example 3, AB is a line segment which is parallel to another line segment CD, right? O is the midpoint of AD, means OA will be equals to OD. You have to show that triangle AOB is congruent to triangle DOC, right? AOB is congruent to triangle DOC, and you have to also show that O is the midpoint of BC, right? So we will take these two triangles, triangle AOB and triangle DOC. Here you can see that angle ABO, that is this angle, triangle ABO is equals to triangle TCO, right? Why? Because of alternate interior angles. This line CD is parallel to AB, and a transversal, that is BC, is intersecting these two parallel lines, then the alternate and interior angles will be equal. Another thing here you can see is angle COD, right? Angle COD, this angle is equals to angle BOA, right? Vertically opposite angles are also equal, and we are given that side OA is equals to side OD. This side is given that these two sides are equal. So by AAS congruency you can say that these two triangles are equal. So that's why if these two triangles are congruent, then we can say that side CD will be equals to side BA and side OC will be equals to side OB. Why? Because of CPCT, right? So second part which we have to prove was O is also the midpoint of BC. For O to be the midpoint of BC, OB should be equals to OC, that we have just proved here, that OB is equals to OC by CPCT. So in this manner you can solve these questions. So exercise 7.1 is based on these three congruency criteria, that is SAS, ASA and AAS, right? So you will solve this exercise 7.1 and I'll send the solution tomorrow, but first you have to try exercise 7.1 by yourself. And in the next video we will talk about isosceles triangle, and also we will prove that how three sides of equilateral triangles are equal.